Okay, we move on. Unfortunately, I forgot to tape the previous hour, but luckily for those who are following this course outside the group, we have a very nice solution on internet here, so you can just find it. We just went through these exercises here, page 315, as well as page 315. Okay, so we kind of concluded that we were able to find the supply curve here given by the part marked here. Okay, so actually not everything. These numbers, it doesn't work. These numbers and these numbers. Okay, there was something remaining in the final parts of exercise 3. There's a B question there, this one. If 100 identical firms are in the market, what is the industry supply curve? Okay. So now we are kind of looking at a situation which is not an individual supplier, but a market of suppliers. Okay, and we have information that in this case there are 100 identical suppliers. Then it's straightforward, isn't it? Because we have the different prices here. That means that a certain supplier here, for the price of 38, he will supply 8. Okay. Of course, if there are 100 equal suppliers, they will supply 8 each one of them. So as a total, all these 100 would supply 800, or 100 times 8. Okay. So for the price of 38, there will be a supply here of 800 units of this product. If we move to a price of 45, then each supplier supplies 9, there are 100 of them, so there will be 900. Okay, so you end up with these as the final market aggregated supply curve. You just take each of these numbers, 8, 9, 10, 11, and multiply by 100 to capture the fact that there are 100 identical suppliers. Normally, that is not what we see in reality. It would be slightly different producers, so we would have to add different numbers here, not as simple as this, just adding same numbers, which totally of course leads to the simplified version of just multiplying by 100. So in this case it was kind of easy to derive the market supply curve, which is given here in table 7. Okay. Then we move to exercise 4. Suppose you are the manager of a watchmaking firm operating in a competitive market. Your cost of production is given by C equals to 200 plus 2Q squared, where Q is the level of output and C is total cost. The marginal cost of production is 4Q, the fixed cost is 200. Okay. We didn't really need that information in addition, did we? We have given a total cost function here as 200 plus 2Q squared. Okay. Of course, if you want to separate these into fixed and variable cost, this is obviously the fixed element. It's not related to what happens with Q. And then, of course, the whole part of these must be variable costs. Okay, so these are fixed costs and these are variable costs as a function of Q. Okay. What did I think about now? I forgot. It furthermore says here, it's added here, that the marginal cost, of course you can find the marginal cost directly by just taking the derivative of this one, can't you? Which is 4Q, or if you like 2 times Q to the power of 2 minus 1, moving from that one to that one. So that you can use that one to find it, but it was also given here in the text as kind of additional help, so to speak. And it's also mentioned here that the fixed cost is 200, which you kind of are able to derive without kind of needing that information. So we kind of get some help to a sense here. Okay, we are told that this one is 200, that is the fixed cost already, although we should be able to kind of find that out ourselves. If the price of watches is $100, how many watches should you produce to maximize profits? Okay. So in A, now we want to do this without numbers but with a function. Okay. Previously we had this table maximizing profits through the table. Now we do it directly with a function. So what is the profit here? It should be a function of Q, quantity. It is found by taking the price in the market, which is given here in A, which is 100, times Q. This is of course the revenue, and then we just subtract the total costs, which are 200 plus 2Q squared. This is our profit function. Okay. So then we just take derivatives here. We can of course get rid of that parenthesis, so it's 100Q minus 200 minus 2Q squared, and taking derivatives here we get 100 from that one has a derivative of 0, and it's minus 4Q to the power of 1. That should equal 0. And as you probably also see here, this is the marginal cost, this is the marginal revenue. So you could alternatively, by knowing that, just equating marginal revenue to marginal cost, or actually in this case, as it's a competitive market, you could just put price equals to marginal cost. As you probably remember, we kind of ended up with this result, didn't we, when we looked at profit maximization in a competitive market. The price is given, it's 100, and it should equal the marginal cost, which also is given here as 4Q. So it's kind of really very easy here to just put this one up, knowing this one, without going through this argument. Okay. Of course, you end at the same, no matter how you do it. So this turns out that Q star, the optimal production quantity of watches here, it turns out to be 100 divided by 4, which is 25. So that is the answer to question A, isn't it? How many watches should you produce to maximize profit? You should produce 25 watches. B. What will the profit level be? Then of course we have to take our newfound optimal amount and enter it back into the profit function to find out how much profit we would earn in this situation. So that means simply taking this number, entering back for Q into this function, that would produce the desired result in B. So then we get pi star, and then we put a star on pi, we give a signal that this is the optimal profit. Okay, and we find it by equating Q to 25, and we then get 100 times 25 minus 200 plus 2 times 25 squared. This is 2500. This is 25 squared. How much is that? Let's look at the solution. Q equals 25, yeah, we got that, and then we just enter it back, and it turns out to be 1050 if I have computed this correctly. Did you get that? Did anybody end up with getting these to be 1050 as a total? That means that this one must be 1450, must this part be. Yeah. Okay, that will be straightforward. Then there's a C. At what minimum price will the firm produce a positive output? That means that we can kind of use the argument that we used previously here, can't we? That we must kind of cover the average variable cost. So if you look at the solution here, I simply take the average cost here, and for the point we found here, Q, which is 25, then it's 2 times 25 squared, which is of course the variable cost. Recall that the variable cost here was 2Q squared. Okay, so this is the variable cost at the point 25. We divide by 25 to find the average variable cost. So that price of 50 should be the point where we pick the supply curve, as well as the point where the production should stop. So if you're going to move under that point, you should stop producing. That's kind of the argument we made. Although the profit may be actually negative in that case, or even zero, we kind of made an argument for that, didn't we? So that should be straightforward. I think there's even another exercise here, yes. Again, kind of the same thing to practice. Suppose that a competitive firm's marginal cost of producing output Q is given by MCOQ as 3 plus 2Q. Slightly different here. In this case, we haven't given the total cost function, but the marginal cost function is given here. Assume that the market price of the firm's product is $9. What level of output will the firm produce? Of course, when you have the marginal cost function and that one only, and you have the price, then it's just to use that equation directly, isn't it? Price equals marginal cost. You can put it up directly. So exercise 5, we have given MCOQ as 3 plus 2Q, and we have given the price as 9, and then of course it's just to equate the marginal cost and price to find the competitive solution for the supplier. So we just put marginal cost equal to price and solve for Q. Okay, in this case this is straightforward. Three plus 2Q equals to 9, and then we get that wasn't promising, was it? Okay, 2Q equals to 9 minus 3, 2Q equals 6, and Q equals 6 halves, which turns out to be 3, doesn't it? Let's control on the solution here. Yeah, 3 was the answer for the level of output the firm will produce. What is the firm's producer surplus? Okay, then we need to know what the producer surplus is. And if you recall, if we have a supply curve here and a demand curve here and a market price here, this part is the producer surplus, this part is the consumer surplus. Now we're asked to find the area of this triangle if the supply curve is linear. Now we kind of don't have the supply curve here directly, but we have the marginal cost curve, which kind of constitutes the supply curve, doesn't it? So we can use that one. Now if you look at the solution here, of course this marginal cost curve is a linear curve in Q. So this will, if you plot this one, it will be something that starts at 3, doesn't it? If Q is 0, it starts at 3, goes up like this. And if Q equals 3 times 2 is 6 plus 3, then you get, for Q equals 2, then you get 9, don't you? Then you get 9. And the price is 9, so it kind of looks like this, doesn't it? This is the price at 9, the market price, and this is the marginal cost curve that intersects that line. So we're kind of interested in this area. Okay, this is 3, this is 9, this is 2, isn't it? So we want to find the area of a triangle which has a baseline of 2 and a height of 6. That should produce an area of 2 times 6, which is 12, and we have to divide it by 2, so it should produce a surplus of 6 in my head. Okay, let's see if that's what we get here. No, I was not right here. Okay, it starts at 9. Yeah, I did. It doesn't. This one is 3 actually. It's not 2. Sorry about that. So if you draw this curve, the marginal cost curve, and you have the price curve at 9 here, it starts at 3. That was correct, but then it kind of intersects at 3 here. So this distance is 3. This distance is 9 minus 3. So you get 9 minus 3 times 3 divided by 2, which turns out to be 9. 9 minus 3 is 3 times is 6 times 3, which is 18 divided by 2, which is 9. Okay. Of course, consumer and producer surplus becomes very interesting in the next chapter, which we will return to next week after the guest lecture on Friday. Okay, question C. Suppose that the average variable cost of the firm is given by $3 plus Q. Suppose that the firm's fixed costs are known to be $3. Will the firm be earning a positive, negative, or zero profit in the short run? So we kind of add some more here, and then we need to nest these together to see if we are able to actually calculate the profits. That's kind of what we need here, to calculate the profits in this case. We know the solution. The quantity should be something which I already have forgotten. It should be 3. And if you look, you can look at the solution here, what I've done. Okay, we have given that average variable costs of ABC equals 3 plus Q. The average variable cost is the variable cost divided by Q by definition. Okay, so we can use the knowledge of the average variable cost to find the variable cost, can't we? By just multiplying through here. So ABC times Q produces the variable cost. Okay, that's what has been done here. Okay, so then I take the given average variable cost of 3 plus Q and multiply by Q, then I get 3Q plus Q squared. So that is the variable cost. Then of course, knowing that the fixed costs are 3, I can find the total cost. Here is a typo. This A should not be there. Okay, I find the total costs by adding the fixed costs and the variable costs. Okay, so be aware of that. This A should be away. Okay, so what I'm actually doing here is that I'm using what I found here, the variable costs, and I add the fixed costs. Then I get 3 plus 3 Q plus Q squared. When I have the total costs and I have the solution here, then it's straightforward to find the profit, isn't it? The price is 9, sorry, the quantity is 9, the price is 3, no, the price is 3 and the quantity is 9, and the price is 3, yeah, no, the quantity is 3, sorry, the quantity is 3, yeah, price is 9, 9 times 3 produces the revenue, and then I'll just subtract the total costs for this quantity of 3 as long as I have the total cost function. Then it turns out that 9 times 3 is 27. Of course, these parentheses can be calculated. 3 times 3 is 9. 3 times 3 is 9. 9 plus 9 is 18 plus 3 is 21. So it's 27 minus 21 turns out to be 8. So it's a positive profit in this case. So in this case, we kind of use the trick. Okay, we were given the average cost, and then of course we need to know how the average cost is calculated by just dividing the variable cost on Q, and then we use that to find the variable cost, which Then we could add the fixed cost to get the total cost, which we need to calculate the profit. Okay, the profit is always revenue minus total costs. You never mix these average cost elements into profit calculations, unless you want to look at average profits, of course. Of course, you also can construct if you like. Okay, this was exercise set 2. Now, as you probably have observed, there are another set left, and we have to kind of take that as we move along. If we look at the plan now, let's do that. Today we are we here? This Wednesday. Today we are here, aren't we? So on Friday there will be a guest lecture. Okay, so that will kind of be outside the curriculum, so to speak, although I urge you to listen carefully to what he says, because it may be interesting in itself, especially perhaps for the sport management students. Then there are 1, 2, 3, 4 lectures left, 2 in week 40 and 2 in week 41. And of course we have to, I would expect we spend the Tuesday and Friday in week 40 on the 2 remaining chapters. So the first remaining chapter 9, will be lectured on Tuesday in week 40, while the final one, 10, will be lectured on Friday in week 40. Then the 2 remaining weeks will be left to the remaining exercise set as well as the previous exam. Okay, so that will be what we do at the final parts of the course. As you probably already have noticed, the exam is on the 21st of October, isn't it? So then you just have to meet up at that date. Then of course you should prepare as good as you can for the exam, but we will return to that. The main points we will look at next week in the lectures is related to the general equilibrium model, you know, this cross, the demand-supply cross, and the effects of political regulations on it. What happens if you force a low price? What happens if you force a high price? What happens if you force tariffs or quotas? You know what that is? You can put you can kind of put an extra price on top of the market price to gain public finances. You could forbid certain producers to supply goods to a certain country. That's quotas or tariffs. Then we will look at taxes, how that works, per unit taxes. I think that's the main points. Okay. From the sport and event side, regulations is actually relevant, because especially in US sports there is a lot of regulations. There is salary caps, for instance. There is what's it called, Eric, this drafting system in the States, where these best guys are picked by the worst clubs. Yeah, you know that in the States, to kind of have a reasonable and certain outcome in the sports economic scene in the States, they kind of let the worst clubs pick the best new players, and the other way around. We don't have that system in European sports, as you probably also know, so there's kind of major changes here. But in the sport, definitely in the sports scene, there is a lot of regulations related to how the financial structure is kind of running. So these will be important in that sense. The same, of course, holds as at least in Norway. When we look at the event scene, there's a lot of subsidies related to events. For instance, the local jazz festival receives a certain amount of money from the government each year, and a lot of cultural activities in Norway is kind of in different ways subsidized, either through the wage system, that certain artists get guaranteed wages, or that certain events or festivals are given money to kind of run. So there is a lot of governmental or political intervention in these markets that interests us mostly. So this part is to some extent relevant in the sport and event scene. But as you probably know, there will be another course here that kind of follows this, which is hopefully slightly more advanced. Not necessarily meaning that it's more difficult, but it should kind of look at more more sport and event related problems. So things like price discrimination, for instance, and bundling. You know what bundling is? Bundling means that you, for instance, at the festival you can buy one ticket that brings you into several parts of the event. Okay, that's, you kind of mix together several tickets into one, and that of course give you the option of kind of targeting special parts of the consumer market. So pricing in general is something which is very relevant when it comes to sport and event, the sport and event scene. So that's what I intended to do today. So if there are no more questions, no more comments, we stop here. And by all means, I will of course introduce our guest on Friday. He is a former president of the Norwegian Football Association, so he is a big man. You have to treat him with respect. He has, like me, a bad hearing, so if you intend to ask him questions, you must speak very loudly. Okay? Some of the Norwegians know who this is, I assume. Yeah, you also know that as he doesn't hear very well. Yeah, so you are used to him. Okay. So I will see you briefly on Friday. Okay. Then you must watch the game tonight, which is between Molde and Stabæk, which is the semi-final in the Norwegian Football Championship. Very important match, 8 o'clock and on NRK TV.